everyone, welcome to Mechanical Software Education channel. In this video we are going to learn about the stress analysis of a rectangular bracket by using Ansys. Look at this drawing. A rectangular bracket is placed here with 3 holes, 2 holes having a same radius of 10 and the largest hole having a radius of 20, and it is situated from the left hand side. The distance is 100 and the outer enlargement portion is given as radius 30, and the size of this rectangular bracket is given as 60 as the height and 100 as the width. Okay, so all the dimensions given in the drawing is in millimeters, and the extra parameters what we are going to give in Ansys is Young's modulus value and also Poisson's ratio. So in this problem we are going to take the condition as a plane stress condition with thickness. So the thickness value is given as T as 20 mm, and the plane stress, so we already know that plane stress, it is a state of stress when all the stresses acting in a single plane, that is the direct as well as shear stresses perpendicular to the plane, and it should be equal to 0. Okay, and the force what we are going to give in the largest portion of the hole, and the particular point here we are going to give the load as 5 kilonewton. Okay, so with the help of these parameters we are going to draw the rectangular bracket, and we can solve with the help of Ansys. Let me move on to Ansys. First of all, start with the preferences. Go to structural, because it is a structural problem. Preprocessor, element type, add your element. It is a solid element. I just chose a quad 8 node 183, and the explanation for this quad 8 node 183 is available in the previous video. So we must use options as stress strain, plane stress, plane strain conditions. So in this problem we are going to assume as plane stress with thickness, and give OK and close. We need to give the thickness value here in a real constants, thickness as 20, and give OK. Now go to material property and the material models. You need to go for material, structural, linear, elastic, isotropic, and give 2E5, that is 2 into 10 to the power of 5 Newton per mm square, and the Poisson's ratio is 0.3. I think we can check it out. So 0.3. So give OK and close here. And we completed the material properties. Now go to modeling. We need to create a model, and we need to go for a rectangular model, and also we need to go for a circle. Okay, now go to area and create the rectangle first. Go to rectangle, 2 corners by 2 corners. It is easier to draw a rectangle with the help of the starting point as an origin, and the width what we are going to give is 100, and the height is 60. So give OK. So you can easily created a rectangle with the help of a rectangle command, and go to circle, and on that circle we can go for a solid circle, and the starting point should be in this region. So the midpoint is in this region, because we need to draw a circle in this region, and the entire length of this rectangle is 100, and the half of the entire height of the rectangle is 60. So take the half of the value so that we can easily find the exact center point, and the radius is normally it should be the exact height of 60. It is a half of the value, as radius is 30. So give OK. So it is easier to create a circle and also a rectangle. So we need to add this 2 areas with the help of operate booleans by add, then pick all the area. So the entire area is selected as a single area. So 2 areas were created. One is a circle and another one is a rectangle. So now we just add 2 elements as a single area. Okay, so now we need to go for drawing another circles to create a hole. Go to solid circle, and again we just go for 100, and the half of the value is 30, and here the radius is 20. So give apply, because we need to create another holes in this direction. So here you can see the distance from the left hand side to the center area of the hole is 20, and the height is 15 here, so we can create the first hole here, and with the help of 30 plus 15, that is 45 as our height, we can create one more hole in the top region. So the radius of the two holes is given as 10. Okay, so now we need to go for x value. X value is 20, and y value is 15, and the radius is 10. I give apply. So the first hole of the same radius as 10 is created here, and we can go for the second circle with the same radius of 10. So x as 20, y value we can add from the base. It is 15 plus 20, it is 35. Likewise we can check here 30. So 30 plus 15, it is 45. So 45 is the height, and the radius is 10, and give OK. So now we created two equal holes and also one bigger hole of radius 20. So totally we have 3 holes, and we need to go for operate booleans and subtract areas. So we can select the entire area first. So this is the base area, that is the connectivity of rectangular and also a circular component, and we just add the entire two elements into, or two components into, single component. Okay, so now we just select the base component first and give OK, and now select the circle, and now give OK, and with the help of this Boolean algebra subtract, we can subtract with the help of Boolean algebra. So with the help of this algebra, we can easily create a hole, three different holes in the bracket. Okay, now we need to go for meshing. Go to size controls, manual size, pick the area, and select all areas. So we need to go for discretization process. So we need to give some numbers here. We can give 1 up to 20, 30, 40. That is depends on your system capacity or requirement, and also the size of the drawing. So here I need to go for 5 as my element length. So this is user defined value, so you can easily give the value as your way. So you can give 1, 2, 3, 4, 5, 6 up to 100 also you can give, and go to meshing. You can create a mesh for areas. So free mesh, I just use free mesh for this, pick all. So it is automatically created. So the number what I give is 5. So if you give a value of 10 or 20, the element sizes might be bigger. Okay, if you reduce the value, so the meshing region, the distance of this quadrilateral element, it should be of a closer, and some elements should be, if the element should be closer, so your results should be given it just almost closer to the exact solution. Okay, so now go to we already completed the boundary conditions process, so we need to go for applying the loads. So go to apply structural displacement on lines. Again select the top region first, and again in this region. So we need to arrest all these things, because it is a fixed one, so all degrees of freedom should get arrested in the two holes of radius 10. And now we need to apply a force or moment in the particular node. Okay, so select the node here. So I just pick a random node in the it shows that it is exactly at the center point here, or it should be in this semicircle, it should be of a center point. Okay, just select this node and give OK, and give y value as, we can check the value here, EF value, that is 5 kilonewton. So it should be in a downward direction, so give minus 5000. So give OK. Now your boundary conditions was completed. So in the structural displacement we selected these two holes to arrest all these things, and also we are going gave a load in the particular node of 5 kilonewton. So now go to solve this problem. Current LS, that is current load step. Okay, the solution is done, and now we can check our results in plot results. Let's check the deformation shape first, and how much deformation happens in this largest hole due to the load acting in the particular node region. Okay, so now we can check the contour plot and nodal solution, degrees of freedom solution, displacement vector sum. So this is the exact displacement value, that is 0.035604 millimeters for my problem. And if you want to check the stress value in terms of one measure stress, you can get 96.5042 Newton per mm square. That's a exact maximum value for this rectangular bracket. So if you want to get the exact shape, we can check with this display of element. Go to on. Now the thickness is shown here. So the maximum stress is acting in the particular node where we gave the force as 5 kilonewton in the particular node. That's why the stress is maximum here. So it should be in a downward direction. If you want to get the exact value for this circular region, so you can select the entire region and give the equal load for getting the exact value for stress, or in this particular region, or in this particular circular region. Okay, so now we can easily analyze, or we can easily animate with the help of deformed results. That stress, we calculated the stress value earlier. We can check the stresses acting in the largest circular region. Okay, so this is the exact answer for this rectangular bracket for stress and one measure stress. So we can view in this way of front view. So the maximum load is acting in this region, that's why the deformation happens, and the stress is also maximum in this region. Okay, so hope you can understand, guys. Thank you very much. So subscribe my channel and support me. If you really gained more knowledge through this video, press like and comment. Thank you very much.